All right, so today we're going to talk about comparing fractions with like and unlike denominators. And we are going to use models, okay? So we talked about this a little bit already, but we're going to look at some patterns and some strategies. All right, so instead of saying which one is greater or less than, or which one is bigger or smaller, or greater or less, I'm just asking you to compare these fractions. And so I think when you're comparing fractions, the good thing to do is look at the denominators, okay? So I have this green arrow right here, and we notice, oh, both fractions are in sixths, right? So what does that mean? That means they were both cut into the same amount of pieces, all right? So what does that mean? So it means the same amount of pieces are in a whole, and that means that the pieces, the individual unit pieces are the same size, okay? So if this first pie has 6 pieces and this pie has 6 pieces, that means their one piece is the same size, right? So really, all we have to do is look up at the numerator, because if the pieces are the same size, then we have to see how many pieces did someone have. So here, if someone had 1 piece out of 6 and someone had 5 pieces out of 6, which one's greater? Right? Which one's bigger? Well, the 5, 6 would be bigger, right? So what would that look like if we had to put a symbol here? It would look like this, right? Because it would read 1/6 is less than 5/6, which ultimately means 5/6 is greater than 1/6, right? All right, let's look at another one. All right, here we go. So we have 5/8 and we have 2/8. So again, first step I want to do is I want to look at my denominator. My denominator, boom, boom. Great, these are both 8ths. So again, my denominators are the same. So that means, all right, there's 2 pizzas here and the pieces are the same size. Okay, so now I don't have to worry about the denominator. I can just look up here and say, okay, 5 out of 8 pieces, 2 out of 8 pieces, because I know the 8 pieces have to be the same size. So which one would be bigger? 5 out of 8 pieces or 2 out of 8 pieces? 5/8 or 2/8? And we can clearly see with the picture which one is greater, right? 5/8 is greater, right? So what would that look like with the math symbol? 5/8 is greater than 2/8, okay? Let's try another one. All right. Again, there's that green arrow. The first thing I want to do is look at my denominator, 4ths and 4ths. All right, so great. That makes my job easier because I know the pieces now are the same size that I'm comparing. So 1/4 or 3/4. Okay, so 1 piece out of 4 and 3 out of 4. And we know that the 4s are equal sizes. So that's what makes the job easier. So again, if we look at the picture, right, 1/4, and these are the same size, right? These pieces are the same size. So 1/4 or 3/4. Well, 3 is bigger than 1, right? So 3 is going to be bigger. So 3/4 is larger, bigger than 1/4. And that's what it would look like. And we could read it as the sentence, 1/4 is less than 3/4. Okay, here we go. Boom, the green arrow. Looking at that denominator, the denominator says thirds. So great. The 2 fractions I'm comparing both have the same denominator, which makes my job easy because now I know that they are equal sizes. So now let's look at the numerator. Help us. Well, is which number is bigger, 1 or 2? Well, 2 is bigger. Well, let's look. Does that make sense? 1 out of 3, 2 out of 3, 1/3 or 2/3, right? Which one's bigger? The 2/3 is bigger. So 1/3 is less than 2/3. Okay. Here we go again. So again, the first thing we want to do is look at the denominator. If the denominator is the same, then all we have to look is the numerator to see which numerator is bigger. And that will give us the answer. So here, the denominators are the same. So we can look up at the numerator and say, okay, which is bigger, 6 or 3? Well, 6 is bigger. And if we want to double check with our picture, right, 6/8 out of 3/8, 6/8 is bigger. And we can clearly do that because the pieces are the same size. So when the denominators are the same, you can look at the numerator, and whichever numerator is bigger, that will be the larger fraction. 6/8 is greater than 3/8. All right, so let's talk about the denominator, right? We know the denominator means it's the amount of pieces in the whole. So the best way to think about, splitting things up is, thinking of you and your friends having a candy bar or a piece of cake and having to split it up into equal pieces, right? So if you have a cake, let's say you and your friend, so you split it in half, right? And look at the sizes of that. Not bad, right? Then another friend comes in. Well, now you have to split it into thirds. So what happens, right? The piece gets a little bit smaller. Okay, another friend comes. So now there's 4 of you. All right, you want to have equal pieces, so you split it into fourths. It gets yet a little bit smaller. All right, someone else comes in. Now you have 5 of you. You've got to split it up equally. The pieces get smaller. So notice as the denominator gets bigger, right, the slices get smaller. Because, let's face it, the pie is the same size. The pie hasn't changed. So we just have to, make the pieces smaller so it'll go further, right? So we just talked about if the denominator is the same, it's really easy because we can look at the numerator, right? If we know that we're looking at fourths, and it's fourths and fourths, and we have 1/4, and then someone needs 3/4, right? The pieces are the same, so we can say, oh, is 1 or 3 bigger? Oh, 3 is bigger. 3/4 is bigger than 1/4, right? And now we know that, okay, if it's one slice and the denominator is getting bigger, we know that, as the denominator gets bigger, the pieces get smaller, right? So let's just keep that in mind, right? As the denominator gets bigger, that's the more people we have to share with. And the more people we have to share with, the smaller the piece gets. All right, so let's look. Well, let's look at our denominator. 4/8. Oh, I have a red arrow. Because guess what, friends? It's not the same. So it's not as easy as it was before. But I know that if I have 4 friends or have 8 friends, right? 4 friends, the pieces would be bigger. So let me look at my numerator. Oh, my numerators are the same. Okay, so that helps me because I know that, okay, fourths are bigger than eighths if we're talking about the units. Okay, we have the same amount of, so if I know fourths are bigger than eighths and I'm taking one of the fourths and one of the eighths, then the fourth has to be bigger. And if you look at the picture, 1/4 is bigger than 1/8. And now this works because the numerators are the same, okay? If these were different, that would be a different story. But let's try another one. Okay, so 1/4 is greater than 1/8. Okay, so again, I try that rule that we talked about earlier, and I first look at my denominators. They're not the same. So what do I know about denominators? I know, well, if I have to share with 12 people, I have to share with 3 people, well, the thirds would be bigger than the 12s, right? But let me see how many pieces. Okay, so when I come up here to look how many pieces, if these are the same number, then we can generalize and say, well, thirds is bigger, okay? Because if I already know that thirds are bigger than 12ths, and if I'm taking one of the third and one of the 12th, the third is definitely going to be bigger. And we can see that from the picture, right? Now I'm telling you to be careful because let's say it was 1/3 and let's say 1, 2, 3, 4, 5, 6 were colored in. right? So let's say this was 6th, 12ths, and 1/3. I don't want you to just say, oh, well, this is, the third is bigger. No, because 6 and the 1 would be different. Notice right now my numerators are the same. Okay, so if my denominators are not the same, then I can come up and look. And if my numerators are the same, then I can use that same generalization. If they're not the same, then we have to talk about a different strategy, okay? So 1/12 is smaller than 1/3, or 1/3 is greater than 1/12. Okay. All right, so again, let's look again. All right, I have my red arrow because I have 8ths and I have 6ths. So they're not the same denominator. But okay, what do I know about denominators? I know that if I have 6 friends, the pieces will be bigger than if I have 8 friends. That's what I know. Oh, I touched it. So I know that, but let me look at my numerator. Oh, okay, 2 and 2. See, they're the same. So 2/8 and 2/6. 2/6, 2/8. So which one is larger? 2/6 is larger. Okay. All right, let's look at this. So again, I'm showing you the red arrow because I'm looking at the denominators first because I'd like them to have the same denominator, but that doesn't always happen. So in this case, it is not the same, right? We have a 10 and a 5. And then I'm just going to say to myself, okay, well, what do I know about 10ths and 5ths? I know if I have 5 friends, the pieces are bigger than if I have to split it up and have 10 pieces, right? So 5ths are bigger than 10ths. But I have to go and look at my numerator because I can't just make that assumption. I have to go up and I have to look. Now that they both are the same, I have 4/10ths and 4/5ths. My numerators are the same. So now I can use that information that I know about 10ths and 5ths because my numerators are the same. Okay? So I can say that 4/5ths is bigger than 4/10ths. And you can see that from the picture, right? But if you didn't have pictures, you could use that strategy. Okay, let's look again. I look at my denominators, and they're not the same. So I'm just going to talk to myself, and I'm going to say, okay, I have 4ths and I have 6. If I had 4 friends, the pieces would be bigger than if I had 6 friends, because 4ths are generally bigger than 6ths. But I can't just jump on that, so I have to look at my numerators. Ooh, my numerators are the same. So I can't go with the information that I know. And I can say 4ths are bigger than 6, so the numerators are the same. So 3/4 is bigger than 3/6. And you can see that in the picture, right? 3/4 is greater than 3/6. And our last slide, okay? Notice I have 2 red arrows. So my 5ths and my 10ths, they're not the same. But I know 5ths are normally bigger than 10ths, right? Because if I have 5 friends, I don't have to make the pieces as small as if I have 10 friends. So I'm going to look up at my numerator. And my numerators are not the same. And see why they have to be the same? 2/5, 8/10. Now 5ths are normally bigger than 10ths, we said, right? But the numerators here are not the same. So we can't use that strategy. So there are other strategies that we'll talk about in the future, but right now, visuals are the best strategy to use with that. Okay, so we can clearly see in this picture that 8/10 is bigger than 2/5, right? All right, so that's our lesson for today. And so we'll discuss a little more. Oh, no. Are you kidding? Nope. Okay. Excellent. Hope it worked.